Hello everybody, we are the 2015 Green Sea Turtle Habitat Research Group, and I'm Maisie McMillan.
I'm Peyton Wetter.
I'm Hannah Wakeman. I'm Lily Nystrom.
And I'm Vanessa Kennedy.
And our study is looking at the home range and habitat use of immature green sea turtles. So green sea turtles are considered to be an extremely endangered species, and they first hatch on the beach and might make their way out into the open ocean. After 3 to 5 years, they recruit to shallow coastal areas as juveniles. And it is extremely important for our study to study them at their juvenile stage because they are considered extremely vulnerable when they're young and they mature at an extremely slow rate. So green sea turtles spend the majority of their lives in the foraging grounds of the Bahamas. And as you can see here on this map, they're migrating from various nesting grounds in Florida, the West African coast, and Central America, and are all migrating here to the Bahamas. So turtles that migrate to the Bahamas have a great effect on turtle populations everywhere, because if the populations die out in the Bahamas, then the turtles cannot migrate back to their various nesting grounds to continue reproducing. So our study is mainly looking at the home range of the green sea turtle, which is the area that they normally inhabit on a day-to-day basis. And by studying the turtle's home range, it will give us a better understanding of why they're choosing this area. So turtles want to maximize energetic intake while minimizing energetic expenditure, and they do this on the day-to-day decision-making process, and this can apply to predation and foraging. They want to make sure that the benefit of an action is going to outweigh the cost and the risk. So by looking at this theory, it will give us a better understanding of why they're choosing their specific home range.
Okay, green sea turtles' primary source of nutrients comes from seagrass, which grows abundantly here in the Bahamas. And because this is their main food source, it is the #1 factor when determining a turtle's home range. Another factor that significantly influences a turtle's home range is the risk of predation. Sea turtles' main predator is the tiger shark, and there is a theory stating that the mere presence of predation in an area will have significant behavioral effects on turtles. Turtles use their size and relevance to habitat structure and environmental fluctuations to protect themselves, and also choose to reside in areas where habitat predation is low. The significance of our study revolves around the fact that green sea turtles are considered an endangered species. There is also a lack of knowledge on juveniles because most research has been conducted on adult females and hatchlings during the mating season because they are on shore instead of in ocean waters. Home range information will eventually lead to conservation methods because you can't protect a species if their location is unknown. And the purpose of our study is to understand how environmental fluctuations in individual size affect juvenile green sea turtle home range and habitat use in a shallow tidal foraging ground.
Our study site is Starved Creek, which is a shallow tidal mangrove inlet containing a single entrance and exit point. This area consists of the sound, which is the deepest portion, the flats, which is slightly shallower, and the creek, which is the shallowest. This area is unique due to its extremely shallow waters and tidal and temperature fluctuations. Our sample size is 12 juvenile green sea turtles ranging from 34 to 57 centimeters in straight carapace length. In order to catch these turtles, we use the rodeo chasing technique, which allows us to follow the turtles on boats until they are tired enough to be chased and caught by hand. Our reason for chasing these turtles is to tag them using our acoustic tags, which are then attached to the carapace of the turtle using epoxy and zip ties. Our acoustic tags that we use emit a unique series of beeps that can be picked up using acoustic telemetry. We first use the omnidirectional hydrophone, which allows us to pick up signal from all 360 degrees to determine which turtles are in our general vicinity. We then use the directional hydrophone to pinpoint their exact location. And once the turtle has been visually spotted, we take a GPS point of its location.
So we use these GPS sightings to map the turtle's home range. We do this using minimum convex polygon. And this allows us to connect the outermost sightings of the turtle, as you can see here, into a polygon. Then the area within this polygon is identified as the turtle's home range. We hope that looking at this turtle's home range will help us understand why they chose this area. We also use another form of tagging. These are time, temperature, depth recorders. They record data every 5 seconds and are attached to the carapace or shell of the turtle. We need to recapture the turtle in order to get its data, but hopefully looking at this data will help us understand how these factors are affecting the turtle. And here's a table with our descriptive results. We started with a sample size of 12 turtles, but due to potential migration and tag loss, we ended up with a sample size of only 8 turtles whose data we could actually analyze. We categorized these turtles into small and large, based on their straight carapace length, or the length of their shell. These turtles are categorized into small, which is the smallest being about 34 centimeters, and the largest being about 57 centimeters. We are also looking at the area of these home ranges. The larger turtles had an area of around 140 meters squared, whereas the smaller turtles had a home range area of, on average, 220 meters squared.
Okay, so we compiled all the data that we found from our studies and into these maps. And as you can see here, the red dots represent when the tide was low when the data was taken, and the blue dots represent when it was high. And we found a few general patterns from our study. We noticed that turtles seem to reside nearer to shore and not in the middle of the sound. And the most frequent area, as you can see here, is by the creek mouth, which is a shallow, sandy area that has sparse seagrass beds and is lined with mangroves. And we noticed that they also made use of areas that were made accessible by tides. And we also noticed a few patterns between small turtles that were different between small turtles and larger turtles. So, as we said before, smaller turtles exhibited, on general, larger home ranges, and they also seem to prefer shallower waters, and could be seen going pretty far into the creek when tides were high. In comparison, the larger turtles exhibited smaller home ranges, and they seem to prefer deeper waters than the smaller turtles, and very rarely went past the mouth of the creek. So from these results, we came to a few conclusions. We concluded that smaller turtles might prefer these shallow waters because they are under increased risk of predation. Since these turtles are more vulnerable, they'll choose these shallower waters because they're safer for them. As you can see here, turtle 10 chose a home range that was very far into the creek, which is a very shallow area that their large predators probably wouldn't even be able to fit into. And these areas are also lined with mangroves, which offer additional protection and habitat to these animals. The larger turtles may have preferred the deeper waters because they are under a lesser risk of predation. As you can see here, turtle number 4, which was actually the largest turtle in our study, chose an area that was fairly far from the shallow creek and was slightly deeper with a cliffy coastline which can offer additional protection if there are larger predators nearby. And besides, they may not enter the creek because even during high tide, the creek could physically be too shallow for these turtles to enter. So, in conclusion, we hope that the results of our study will provide essential knowledge that will help us with turtle conservation, especially since the risk of coastal development is increasing. So, with the information from our study, we hopefully can make smarter choices about where on the coast we do develop, and hopefully it will help to green turtle conservation, because you can't protect an animal if you don't know where it lives. Thank you to Annabelle Brooks, Dr. Michael Salmon, Abby Gordon, the Keeper Luther Institute, the CEI Sea Turtle interns, the Island School, and the National Save the Turtle Foundation for their help with our study. Do we have any questions?
So why do the turtles choose to migrate to the Bahamas? Is it because of the climate of our waters? Because it's warm?
So the question was why turtles choose to migrate to the Bahamas, and this is because they are coming here to forage on the abundant supply of seagrass that grows here. So because of our shallow waters, the seagrass can grow in this abundantly in the Bahama area. And yes. Any other questions? Yes.
Is there any current legislation by the Bahamas government of where people are allowed to develop, especially on the coastline?
So the question was whether there is a current regulation, and right now there is a ban for that they're not allowed to fish for turtles or capture them, but there have been studies shown that we're actually looking into whether the fishermen are abiding by these rules. And there's actually a later presentation that will tell you more about that. Yes.
How long do you have to chase a turtle before it's tired enough to be caught?
So the question was how long we have to chase the turtles until they're tired enough to be caught, and that varies depending on the turtle. Turtles are very fast, so it can take a while since we're not always going very fast. But it also depends on the swimmer too, because swimming is hard to.
And to add to that, we usually chase it by boat once we have visually spotted it, and we wait for the turtle to take 3 breaths out of the water before we send a swimmer in to chase it by hand.
Yeah.
That was really informative, guys. I appreciate it very much. It was a great study. Could you talk a little bit about your sample size? Like how many turtles were you hoping to track, and how many did you lose, and why do you think you couldn't find them?
So the question was how many turtles we. Could you repeat that?
How many turtles you were hoping to track, and how many you did track, and
Okay.
what the difference was?
So the question was how many turtles we were hoping to track and how many we actually tracked. We were originally tracking 12, but we lost 2 turtles due to migration and just tag loss. So that tends to happen sometimes because turtles can, their tags can come off if they rub up against rocks. So that is unfortunate.
And did you know that because you found the tags without the turtles still chirping?
So the question was if we knew that because we found the tags, and yes, that is what happened. We found the tags, so we knew that they did come off of the turtle.